we don't blow ourselves up, if an asteroid doesn't strike us down, if a virus doesn't eradicate the human species, or if any other catastrophic event, whether man-made or natural, doesn't occur, it's extremely likely that technological progress will not only continue, but accelerate. What will life be like in 2045? Prediction is very difficult, especially if it's about the future. This quote, often attributed to Niels Bohr, captures the essence of our challenge when trying to foresee the events that will happen before this seemingly arbitrary year. So what's so special about 2045? Why not try predicting events in 2050 or 2100? For the longest time throughout human history, and especially throughout human prehistory, you couldn't tell much of a difference between 1 year and 1,000 years ago, or even 10,000 years ago. But ever so slowly, humanity has gone through several critical revolutions that have ultimately shaped our current path, potentially leading us to create what could be considered the first digital gods. The cognitive revolution some 70,000 years ago enabled humans to develop complex language, culture, and the ability to form larger, more cooperative societies. The agricultural revolution, about 12,000 years ago, transitioned us from nomadic hunter-gatherers to the first settlers, laying the groundwork for the first civilizations. The industrial revolutions, beginning in the late 18th century, propelled us with technological and mechanical innovations, enabling mass production and drastically changing our economic and social structures. But only in the last century have things gotten really interesting. Even though it's a common cliché to say that one's own era is special, ours truly is. As we are living in the age of AI, where profound technological changes are set to drastically alter our world. Moore's Law began around 1965, when Gordon Moore, co-founder of Intel, observed that the number of transistors on a microchip doubles approximately every 2 years. This observation marked the recognition of exponential growth in computing technology, highlighting a trend that has largely continued to this day, although there are debates about how long it can sustain due to physical and technical limitations. This exponential growth in computing power has been a crucial driver of technological advancement across multiple fields. As renowned futurist Ray Kurzweil points out, Moore's Law was in effect even before Gordon Moore was born. We just didn't observe its effects because technological progress, while exponential, was occurring on a smaller scale that made it less perceptible. Our brains are not hardwired to grasp exponential growth. For example, when the Human Genome Project started in 1990, progress initially seemed slow, leading to projections that it might take a century or more to complete the sequencing. However, this view underestimated the rapid exponential growth of technology, and to the surprise of many, the Human Genome Project was declared complete in 2003.
I thought that it would probably be the most important scientific discovery in the 20th century.
The general public began to truly appreciate the potential of exponential growth in technology, especially in artificial intelligence, only a few years ago, with the release of several influential generative AI tools, such as GPT-3, known for its language processing capabilities, or Mid-Journey, an AI-powered text-to-image generator known for its ability to interpret and visualize complex text prompts into vivid, detailed, and artistic images. Today, we are even more impressed with AI tools such as Sora AI, a text-to-video generative model capable of generating videos up to 1 minute long, featuring complex scenes with intricate camera movements and characters that exhibit lifelike behaviors. This technology is based on a diffusion model that transforms static noise into detailed videos, frame by frame. It's not hard to imagine that within just a few years, technologies like this could empower anyone to generate complete movies, documentaries, or television shows from a single text prompt. and even alter endings of existing series or films, further democratizing the creation of visual content. But perhaps the most impressive tool of OpenAI is GPT-4 Omni, a model that operates under the principle of omni-capability, allowing it to process and understand various types of data like text, image, and audio inputs simultaneously.
Hey, ChatGPT, how are you?
I'm doing fantastic. Thanks for asking. How about you?
It's easy to imagine a not-so-distant future where everyone has access to their personal AI assistants on everything, capable of teaching skills, providing legal and medical advice, tutoring kids in subjects like mathematics, language learning, and science.
I'm here with my son, and I'd love you to tutor him on this math problem.
The ultimate goal of OpenAI and many other companies like it is the creation of AGI, or Artificial General Intelligence, a machine with the ability to understand or learn any intellectual task that a human can. Ray Kurzweil has predicted that AI will achieve human-level intelligence by the year 2029. He first made this prediction in 1999 and has consistently maintained it over the years. But perhaps human-level AGI is a false goal, because if an AI has cognitive capabilities equivalent to those of the human mind, its inherent processing speed, due to the faster rates at which electronic circuits operate compared to biological neurons, could mean it would greatly surpass the smartest humans on Earth. Imagine the most intelligent person who has ever lived, with access to all human knowledge, and you give it a complex problem to solve, such as finding a cure for cancer. If you were to check on its progress after a week, an AGI with such capabilities might have accomplished what would take humans thousands of years, due to its ability to process information orders of magnitude faster than the human brain. So if we imagine that AGI is created in a lab somewhere on January 1st, 2029, by the very next day, January 2nd, it will have long surpassed the human mind in intelligence capabilities. That is why it's absolutely crucial to develop AI aligned with our interests, as we might not get a second chance to do so. The AI alignment problem is possibly the most important problem our species has to solve, yet today, only a relatively limited number of resources and brain power are dedicated to solving it. Considering this, even the Fermi paradox, which points out the contradiction between the billions of potentially habitable planets and the lack of observed intelligent alien life, might have a chilling explanation. Perhaps our galaxy is littered with the remnants of long-dead alien civilizations that reached a level of technological sophistication like ours, but ultimately failed to solve the AI alignment problem. In a post-AGI world, if humans are still part of it, it will most certainly mean we have solved the AI alignment problem. A machine capable of outmatching any human in intelligence will create the blueprint for the machine that makes the next machine to achieve any of its goals. Automation will skyrocket, leading to what is called a post-work society, where machines perform every mundane and even intellectual task. Any existing job will be performed much better by a machine, potentially leading to widespread unemployment. Obviously, such an intelligent AGI will also be used for good, such as solving complex societal problems like disease. But even if we solve the AI alignment problem, our current political system will need drastic changes to counter the effects of a few companies owning AGI, creating trillions of dollars in wealth, while the rest of society is left to starve. A sort of wealth redistribution system, perhaps even devised by AGI, will need to be enacted to address every job being lost to machines. But even if this political system problem is solved, some critics argue that this would create a false utopia, as many of the now 8 billion plus free of disease tourists who play frisbee all the time still find meaning in their work. Proponents say that, again, AI will be the answer, as the development of VR technology becoming indistinguishable from reality, akin to the Matrix, will lead to constant immersive experiences.
Welcome to the desert of the real.
Boredom will evaporate from our vocabulary. Those wishing to contribute intellectually in a dominant AI world might need to integrate their brains with AI. AGI will create unfathomable new fields in technology and deepen our understanding of the laws of the universe. It might discover new theories in physics that better explain our world, develop nanotechnology, quantum computers, eradicate diseases, and create advanced space technology for exploration. Eventually, there may come a hypothetical future point in time at which technological growth becomes uncontrollable and irreversible, resulting in unforeseeable consequences for human civilization. John von Neumann was the first known person to use the concept of a singularity to describe this potential future event. In his book, The Singularity is Near, Ray Kurzweil predicts the technological singularity will occur by 2045. At this event, an upgradable intelligent agent might enter a positive feedback loop of self-improvement cycles, each new and more intelligent generation appearing more rapidly, causing an explosion in intelligence that would ultimately result in a powerful superintelligence far surpassing all human intelligence. As is the case with a singularity in a black hole where we can't predict what's happening, so it is with the technological singularity, where it's impossible to predict the future beyond. It should be noted that many of these ideas remain speculative, particularly in predicting when they will occur. But even with slow, gradual technological improvement, if we don't destroy ourselves, we will eventually stand in the presence of something far more intelligent than us, and the issues we discuss today will remain relevant.